All right, we're going to do a quick review for the Math Excel for the end of Chapter 5 here. So Chapter 5, Sections 1 through 4. There's going to be some Math Excel questions, and I want to do a few of these just as warm-ups to get your brain in gear for remembering our exponent rules and being able to do operations with polynomials. So we're going to focus on some of these exponent rules. So let's get rolling. So we're going to do these first three. So I invite you to pause the video, try them, and then come back and listen to the explanation if you need that. So for the first one, x to the 10th over x to the 7th. Remember the rule when you're dividing with the same exponent or the same base, we subtract the exponents. So 10 minus 7 would be x to the 3rd. What some people do is they think, okay, where do I have more? I have more x's on the top. How many more? 3 of them. Whichever way is easier for you to do. For number 2, we have to remember what's going on with the negative exponent. So again, try the question, then pause. Think about what it means to be a negative exponent. Where do those actually belong? So what I would do first is I would move each of these where they belong. So this x to the negative 9th in the bottom really means it's x to the 9th in the numerator. That x to the negative 3rd on top comes down to the bottom. Then it's easier for me to look at. So I can do my exponent rules here. So subtracting the exponents. So 9 minus 3, that would leave me with an x to the 6th as my final answer. If it's easier for you just to think where is there more, there's 6 more on top, that's great. That works the same way as well. All right, number 3, again, pause the video, think about what anything to the 0 power means, try it. All right, so my base is negative 3, doesn't matter what's inside those parentheses, because it's raised to the 0 power, my answer is always 1, uno, just that, because when I think of it, when we do the dividing out, if we have 0 as our exponent, that means everything divided out. It would be the same thing as saying like x to the 7th divided by x to the 7th. That's x to the 0 power. That means all of the x's divide out. So anything to the 0 power is 1. All right, let's try a couple more here. Again, pause the video. Make sure you can think about what's happening with each of these. So let's go ahead and just take a look at number 4 to start with. Go ahead, pause, see if you can multiply those together. So remember, we reorganize. We think of this in our head, putting our coefficients together and our variables together. So 2 times 8 would be 16. Multiply with the same base, we add the exponent. So just be careful that you sort and organize and think about what's happening with each of those terms. All right, let's try another one. Think about what it means to take a product like that and raise it to a power. So remember, that means the same as like 3x to the 6th, y to the 7th times itself. So that's one way to think of it. That means you're taking everything on the inside and squaring it. Another way to think of it. So if you prefer to kind of write it out, that's great. So we can multiply together the coefficients. So 9. X to the 6th times x to the 6th would be x to the 12th. And then y to the 7 plus 7 would be 14. So some people think of it that way. Another way to think of it is take each of those bases on the inside and you're going to raise them to the 2nd power. So I would take every single one of the bases on the inside and I'd have to square them. Right, that means I need to square the 3, which is 9. Power to a power. Do you remember the rule for that for exponents? Power to a power, 6 times 2, that would be x to the 12th, and then 7 times 2, that would be y to the 14th. It's just a different way of looking at it. If you had a bigger power on the outside, I'd never want to do it like I did the blue way, where I wrote out all the terms. You would want to take everything on the inside and raise it to that power. So it might be a more efficient way of solving. All right, let's take a look at a couple more here dealing with some of those exponent rules. All right, so 2x to the negative 3rd. Pause the video, see if you can figure out what you think it is, and then we'll go from there. So remember what negative exponent means. It means reciprocal, so that means this 2x is really in the denominator, and it's cubed. Notice the whole 2x is in parentheses, so the whole 2x is being raised to that negative 3 power, which is why the whole thing went down to the bottom. Okay, now that means I have to cube everything in there. That means the 2 needs to be cubed, and the x needs to be cubed. That's how you need to think of it. Every single base inside those parentheses needs to be cubed. All right, well, what's 2 cubed? 2 times 2 times 2? That would give you 8, and then x to the 3rd. So we need to cube both. Another way, again, on the bottom, you could have done 2x times 2x times 2x. It gets a little long to write that out, but that's what it means to cube something, right? 2 times 2 times 2, there's your 8. X times x times x, there's your x cubed. So negative exponents, we move to where they belong. All right, that being said, let's take a look at number 7. This can be tricky for people. There is a visual difference here of no what. What's not like what we had in the last one. parentheses. Okay, what does that mean? That means really the only thing that's being raised to the negative 2 power is just the x. That 7 is not inside parentheses with it. It has its own exponent of 1. That means the only thing that needs to get moved then is that x to the second. It's the only part that actually has a negative exponent. The 7 stays put. This is one of the hardest things for people to recognize, but look for what the base is. There's no parentheses there, so it's only the x. Now this, there's nothing you can do to simplify other than move the x to the negative second, so it's done, but be careful what you move. All right, last thing we just need to highlight here again, scientific notation, make sure we're okay on that. First one I want you to write in scientific notation, and then the second one, back to standard so we can see what that looks like. So go ahead, pause the video, see what you can do. All right, so for the first one, how many places are we moving here? 1, 2, 3, 4, 5, 6 to get it in between the first two non-zero digits. So it would be 7.94 times 10 to the, okay, now we are moving to the right here. We're dividing by 10 each time. So that's the negative 6 power. I divided by 10 6 times to move that over. So again, you can try. You can type that into your calculator and see that you get the same number you started with. It's a good way to check. All right, now we're going to go the other way. So what would 72,000 be in standard notation? Go ahead and pause the video. Try it. So the decimal point currently is at the end of the number. So 1, 2, 3, 4 places to get between the first two non-zero digits. So 7.2 times 10 to the, now we're multiplying by 10 to make this number bigger. So how many times do we multiply by 10? Well, 4 times. And again, check it on your calculator. Kind of the rule of thumb, big numbers, positive exponents, right? We're timesing by 10. Tiny numbers, less than 1, you're dividing by 10. You're making it smaller, negative exponent then. Remember, 1 over, so we're dividing. So just some quick warm-ups to help you with some things on your Math Excel.